Good evening, everyone, or good afternoon, depending on where you're joining us from. My name is Sam Nasser, and this is the Azure Cleveland User Group. If you're joining us for the first time, a little bit about our user group. We meet every month, typically every second week of the month. The meetings are free of charge and open to the public. And we cover a variety of topics related to Azure, whether it's infrastructure as a service, platform as a service, or software as a service. You can find all the meeting information for both past as well as present meetings posted at meetup.com at the link listed at the bottom of the slide. We always like to give a big thank you to our sponsors, the .NET Foundations for sponsoring the Meetup website, and NIS Technologies for sponsoring the virtual meeting space. In addition, first and foremost, please keep in mind, participation is always encouraged. And like I always say, the only stupid question is the one not being asked. So always feel free to jump in with a question or a comment, either verbally or in chat. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And we want to keep it casual but organized, meaning feel free to jump in with questions or comments. However, we also want to give our speaker enough time to go through the slides and the demos. And the presentation is being recorded and will be posted on YouTube shortly after the editing process. So for tonight's feature presentation, we have Matthew Hess presenting Get on the Bus, the Azure Service Bus. Matt is also known as the C# Artisan. He is a Microsoft MVP and software engineer for CG Infinity. He is the organizer of the Albuquerque .NET Users Group. And he's worked for a variety of different industries, whether it's legal, financial, bio, or nonprofit. You can find a lot of his interesting videos, short 10-minute clips discussing various C# technologies over on youtube.com/@C#Artisan. And so with that, let me turn it over to Matt. Matt, thank you for joining us tonight.
Thank you very much. I'm really excited to get to talk with you all. So this presentation does tend to stretch to the full hour. There's a lot to go over. So again, interested to get questions and comments as we go. Happy for you guys to turn your cameras on if you want. It's all, I can look over there and kind of see if people are falling asleep or nodding or cheering or whatever's happening or laughing at my jokes. There is at least one joke in here. We'll see if you can spot it. Did anyone catch it? That was it right there. That was the joke. Okay, so let's just launch right in. This is Get on the Bus, the Azure Service Bus. Again, I'm Matthew Hess, and I want to just begin with figuring out how to use my screens. Let's see. Where is my slideshow? There we go. All right, so I'm going to begin with a couple of acknowledgements. First, I just want to acknowledge my dad. He passed away this last year. I really lucked out in the father department. Lawrence Hess was an amazing man, an incredible professional, and just a wonderful dad. So thank you, Daddy. I miss you a lot, and I appreciate everything you gave to me. I also want to thank CG Infinity. That's my employer. We are a consulting shop out of Plano, Texas. They're extremely supportive of these activities. They know that I'm doing this, right? I'm sneaking around. They're very encouraging and supportive. It's a very enlightened place to work. So thank you, CG Infinity. And they also sponsor the Albuquerque .NET User Group, which is great. So we've got a long agenda of things I want to try to get through. We'll talk about what is Azure Service Bus, what a messaging-based architecture is even used for. Why would you want one? Spend a little time with prerequisites and just kind of getting your environment set up. We'll cover basic send and receive, which are your fundamental service bus operations. I want to spend a little time talking about message payload. What's actually in these messages that we're sending? We want to give that some thought. And then 6 and 7 is the really more intense stuff. 6 has got some very sometimes subtle or tricky things with the various receiver modes and options. You've got a lot of knobs to think about when you're working with Azure Service Bus. And 7 and 8, the receiver patterns and errors and fault tolerance, bring it into the real world of how to build an Azure Service Bus application that isn't just a toy. It's actually industrial grade and is going to really run. So that's what we have on the agenda. So what is Azure Service Bus? It's really kind of a weird name, but let's just start with the academic or the kind of text version. So Azure Service Bus is Microsoft's cloud offering for developing message-based applications. So why is it called a bus? Like, what kind of bus are we talking about here? School bus? Double-decker? And honestly, I really don't like the term bus. Like, if you've done electronics, or if you've taken your computer apart, you've seen the bus, right? You know what a bus is, the thing that sits between the RAM and the CPU. A bus is a hard-coded, extremely high-performance, multi-point-to-point connector. And there is nothing like that in Azure Service Bus. It's not high-performance. It's slow. It's message-based. And it's not really multi-point-to-point. It's built to solve a different problem. So I'm not sure where we started calling these things buses, but back in the day, we called this Microsoft Message Queue. And in a way, that's what this is. This is MSMQ in the cloud. And I wish they had just called it Azure Queues, although I think there's something else named that. And if you look at other technologies that are similar, you have like RabbitMQ, Message Queue. And Kafka falls in the same family. Its capabilities are much broader, and it handles a lot of patterns and streaming and things that really, you don't find in Azure Service Bus. But that's what we're talking about. When you look inside Azure Service Bus, there are queues and there are messages. And that's pretty much it. So in my mind, I just think of it as Azure messaging or Azure MQ. So why would you want one of these? What real world problem does this kind of architecture solve? And to explain things, I usually resort to food metaphors because I guess I just really like food. So imagine that you're sitting at your desk and you've been coding away and you realize that you are a little bit hungry. So you know what you're going to do. You're going to get up, wander down the hall where there is a vending machine. And you're going to walk up to the vending machine and you're going to put some money in and make a selection. And then out from the bottom comes some Munchie Crunchos. And you're so happy you've been wanting those Munchie Crunchos. You take them back to your desk and you're good. So what I just described is the opposite of a message-based architecture. This is a synchronous architecture or a direct call architecture. And this is how most software is put together, right? One function calls another function. So let's put this into a UML sequence diagram, which shows us the tightly coupled system. So in this case, we have two participants, the customer and the vending machine. And the customer does an input, makes selection, B7, and the response comes back, which is the snack. Or maybe you get a 404 snack not found error or something like that. So you call a function and you get the response right away. So everything from old school SOAP to new REST to gRPC to memory calls within your application, this is all tightly coupled and synchronous. You make a call, the response comes back right away. So the opposite of that would be a message-based or loosely coupled system. So what does that look like? So now let's say you kept working and those Munchie Crunchos were good, but they didn't really stick. And now you are really hungry. And if you were here in Albuquerque and we were really hungry, there's really only one thing to do, and that's to drive down to the west end of Lomas Boulevard and go to Duran's Central Pharmacy, which is amazing. And if you're ever here, we'll go. I'll take you. So we go into Duran's Central Pharmacy and you go up to the counter and you order some food. And the person at the counter writes down your order on a little notepad, and they take it and they stick it in that metal spinny thingy. They just put your order there. And at some point, someone in the kitchen pulls your order off of the silver metal spinny thingy. It has a real word. And at my last time I gave this talk, somebody told me what it was, and I've forgotten. But so I'm just going to keep calling it the spinny thingy, if you guys are okay with that. So basically, they take your order, they cook it, and then somebody runs it out to you. So let's do the UML sequence diagram for that. This is the decoupled or message-based system. So in this case, we have 4 participants: the customer, the counter, the order queue, and the kitchen. And the queue is the key thing. That's the metal spinny thingy. That's the queue. So when you place your order, the counter enqueues your order. They don't just cook your food. They don't stand there and cook it. They enqueue it. And then the kitchen dequeues your order. They get the message, they prepare it, and then they run it back out to you. Now, in a real, been to a real restaurant? Any of you all been to a restaurant? So you'll know if you've actually been to a restaurant that there's a second queue, right? They put the food up on a little warmer shelf under some lamps and ding a bell, and that's the second message so that somebody can bring it up. But that just makes it too complicated. So we'll just stick with the one queue. So why does it work? Why is almost every restaurant, except for Chipotle, based on this kind of pattern? And it has to do with wanting to really separate your implementation of the counter and the kitchen. The counter requires equipment, technology, skill, staffing that is totally different than the equipment, skill, staffing, technology in the kitchen. They are just separate concerns. And most importantly, they have separate scale factors. So what do I mean by that? Well, let's say it's Thursday afternoon, like it is, and we went down there. You'd probably have one counter person and maybe a couple people back in the kitchen. It's not a very busy time. But let's say we went back on Sunday brunch where it's just slammed. They might have 2 or 3 people at the counter, but 8 or 9 or 10 back in the kitchen. So the counter and the kitchen have different scale factors. You need to scale up the kitchen more rapidly in order to load balance. And if your counter people were cooking, they would just fall behind. It would never work. So decoupling a system, whether you call this microservices or macro services or just good architecture, decoupling it is the key to that separate implementation, separate scale factor. And messaging through a queue is what makes it happen. And if you think about, the most common experiences like e-commerce, when you place an order, there's all these different services. Something has to record the order. Something has to take care of pick and pack. Something has to take care of ship. There's probably an email service sending various notifications, order received, order shipped, order delayed. There's a financial function that has to maybe run your credit card or book some revenue. All these different systems, they are not tightly coupled, right? This system will just send a message out to these 2 systems telling them, okay, we have an order, do your thing. So this is how we build enterprise caliber systems. So Azure Service Bus is for this kind of enterprise caliber messaging, the glue that links together these complex multi-service sorts of systems. That's what it's for. That's why you would want one. Oh, and by the way, we ordered the blue corn enchiladas, and we got them Christmas, which means red and green chili. So I hope you guys already ate dinner. I hope Sam brought you food if you're in person, because it's a little mean of me to show this to you if you haven't had dinner. So, but that's what we got. All right, so now that you know why we want to build one of these, let's get going. So we have to get a few things set up. So this is in Azure, and I'm assuming you have a resource group and a subscription and a way to pay and all of that. The very first thing you need to do is create a namespace. So a namespace is just a container, a named container, and you're going to put your queues inside of it. And it's kind of the billing unit where you can organize several different queues and topics inside of it. And it also kind of creates the security gateway. In other words, later we're going to authenticate to the namespace in order to get access to the stuff inside of it. So when you create things in Azure, you can do it through the CLI or you can do it through the Azure portal. Either way, here's some CLI code, AZ Service Bus, namespace create, you give it a resource group, you give it a name, you tell it where you want it. And after you've done that, if you go look on the portal, you'll see you have a namespace, test bus namespace. That's the first thing, namespace. Second, you need at least one queue to work with. So that also can be done just through a little bit of CLI, Service Bus queue create, with the resource group, the namespace, and the name of the queue. After you run that, your queue is created. You can see it on the portal. It comes up active, and it will have no messages total, no active, no dead letter, nothing scheduled, but it's ready to go. So you made your namespace, you made your queue. Now I'm assuming you're going to write some C# code here. So you need to install the NuGet package, which is azure.messaging.servicebus. And you, in any code unit where you're going to write Azure Service Bus code, you have to say using azure.messaging.servicebus. Last, I'm going to talk about something that isn't really a prerequisite, but it's something you do all the time. So I kind of treat it like that. So when you do, if you've done like database work, you know that the very first thing you always do is create and open a connection. So this is kind of like that. Everything is going to require you to have a service bus client, which serves, it's analogous to like a SQL connection. So there are a couple of ways to instantiate a service bus client. What I'm showing you here is what you might do in a production Azure environment. So this uses the concept of default Azure credentials. This is not a talk about Azure authentication and Entra ID and all that stuff. But the idea here is you're working in some environment where they've set up MFA and different ways to authenticate, where it can be server to server, or a person can enter credentials, or however that works to like actually authenticate a client. So what we do is we create some service bus client options. And in this case, I'm choosing the AMQP WebSockets transport, which is the highest performance. And I'm saying create a new service bus client, passing in my namespace, testbus namespace.servicebus.windows.net, my credentials, and my options. So that's very production ready. For development and testing, you need something a little simpler or easier, and you can actually use a connection string. So a connection string for Azure Service Bus is just like a SQL connection string, except much, much longer, not the kind of thing you're ever going to write by hand. So what you can do is if you run this CLI kind of command, you can actually print out the connection strings that are available to you. You can also get them through the portal. You can browse around and find where you can get the connection strings. And the idea here is just, maybe I'm storing it in my app settings, or you're storing it in, I don't know where you're putting it, web config, some in environment, some configuration place. You read the connection string, and then you can instantiate a service bus client just by calling new with the connection string. So these both work. At the end of the day, you have a service bus client. And I tend to just put that in a shared static function that anything can use, like get me my service bus client for this particular namespace, and it just does it. Okay, so those are your prerequisites. I'm moving a little fast. Any questions so far before we move on to sending and receiving messages? All good? All right, I will take silence as we're all good. So now let's go over your basic operations. We're going to want to send a message and we want to receive a message. So here we go. Let's send a message. First thing, make the service bus client. Second, you're going to make a service bus sender by calling client.createSender and giving it the queue name. So the client has authenticated you to the namespace. The queue is something inside of that. And so now we have a client where we have a sender that lets us send to that queue. Make yourself a message and then await sender.sendMessageAsync, passing in the message. And once that goes, if you go to the portal, you'll see in your queue, you have a message, and it's an active message. That's a basic send. Pretty straightforward. So let's receive it back out. Once again, we start with making a service bus client. We want to know the queue, and then we create a service bus receiver by calling client.createReceiver with the queue name. And then we get our message by calling await receiver.receiveMessage async. And that gives us a service bus received message. Now, it is possible that there's no message in the queue. So this receive message async, it has a timeout. We'll talk about that, but the default is 60 seconds. And if there's no message in the queue, this will return, but message will be null. So you always need to put a null check here. Do not assume that you always have a message. And then if you have a message, you're going to do something with it, and you're probably going to call receiver.completeMessage async. Now, I'm going to spend a lot of time talking about this. We're just going to put a pin in it for now, but I wanted it here for completeness. This is sort of your basic receive. And if you go on the portal, you'll see there's lovely graphs and visualization tools where you can see all of your what's happening in your queues, messages being sent to them and messages being received out of them. So there's your basic send and receive. Now, one thing to remember and keep in mind is that this is a queue, right? So it's first in, first out. It's FIFO. So what does that mean for message delivery order? Let's say we sent 3 messages, M1, M2, M3, and they're all in the queue. And then a receiver calls receive message async. It's going to get M1, first in, first out. And unless you kind of muck about a little bit, Azure Service Bus can enforce strict FIFO ordering for you, just like MSMQ did. So we'll see some of the edge cases where you can get things out of order, but in general, you can count on it to order the messages if that's important to the business logic of your application, and it may be. Now, this next slide can be a little bit of a problem. This is the difference between a queue and a topic. So most of us have heard of the term pub sub, where you publish and there's lots of subscribers. The thing is, there are different ways that this gets implemented. One pattern that you see is where a publisher can put a message up in a topic, and it just sits there, and anybody can come along and read it. Like, oh, I want to read it. Oh, I want to read it again. Oh, somebody else wants to read it, get it. And then eventually it times out. That's a very classic pub sub way of doing it, where you just put the message up and it's there and people can go get it. So for example, if you've done any Salesforce programming and if you've used the Salesforce, oh, I forget what they call it, the event hubs in Salesforce, that's how that works. And Kafka does this also. The Kafka has a way to set it up. So it's like this. That is not, what I just described is not what Azure Service Bus does with topics and subscriptions. With topics and subscriptions, it's really just a way, it's just like a multi-queue. You've got one sender and multiple queues that are going to get it. It's just that the queue is now called a topic. And for the purpose of getting them, it's called a subscription. So let's say, and you set up these subscriptions explicitly up front. You go in the portal and you create subscribers. So let's say we had a topic with 3 subscribers and we sent a message. What effectively happens is that message, a copy gets placed in each subscriber's queue. So these are queues. These function exactly like queues. The topic itself has no counts. But if you look at a subscription, it has counts: message count, active, dead letter, max. So that's what tells you that a subscription is really just another name for a queue. So the way this works is, let's say that our sender sent two messages, M1 and M2. And then each subscriber got both M1 and M2. And then subscriber 1 came along and received it. Well, they would get that message out of their queue. It would be gone. They can't go get it again, but it has no impact on anybody else's messages. And then if subscriber 4 comes along and subscribes, they don't get M1 and M2 because they're too late to the party. So this is really pretty rigid and very simple. It's just a convenience if you want to be able to fan out, send a message once and have 2, 3, 4, 5 different things potentially pick it up. And it's good for an enterprise pattern if, for example, like your order service is like, I want, you place an order, I want to let accounting know, I want to let fulfillment know, I want to let email notification know. And so you fan it out by using multiple subscribers. So those are topics and subscriptions. The code for sending and receiving is identical to what you do for queues. So that's just something to keep in mind. You do have that option. Okay, so that's my coverage of like your basic send and receive. It's pretty straightforward. Any comments, confusions, or questions so far? All good? Okay, somebody go off mute and say all good. I just need to know someone's alive.
All
Yeah,
good, but I have a question, Matt.
I mean, it's spooky. You sit up here and like, I know there's people out there, but it's always helpful to know that I haven't slipped into the matrix. Okay. So
I do have a question.
Yes. Yes.
Oh, I was just about to ask about the payload, and here we are. That was my question.
Awesome. We are aligned. So I do want to talk a little bit about what on earth you are actually putting inside these messages. And there's a little more to this than you might think. So I make a distinction between two kinds of messages, and I call them heavy messages versus light messages. Now, these are Matthew terms, right? You're not going to see this in a book by Martin Fowler or some famous, really smart person, unless someone decides that I need to be famous, which isn't happening. So I call them heavy or light. Sometimes they're referred to as stateless or stateful and stateless. But let me just describe what I mean with a concrete example. So let's imagine that you are working in a sales organization and your job is to prepare bids. And the workflow in your company is you prepare a bid and then you have to send it to your boss for approval. They review and approve, and then if they approve it, it gets sent out. So you compose it, you submit it, it gets approved, and it goes on out. Now, let's imagine that this is happening in 1997. So you have composed your bid using WordPerfect, and you have printed it out on the new Okidata.matrix printer, and you've peeled off the little squigglies, and you've stapled it, and then you got a Post-it note, which is an old technology, and you wrote on this, "Hey, Todd, please review." And you put it on there, and you walked it down the hall, and you stuck it in the little wire inbox in Todd's office. Now, Todd is out golfing, okay? But eventually, we hope that Todd comes back from golfing. Todd picks up your bid and reviews it. So here's the key. The message is the whole packet, and it contains everything Todd needs. Todd doesn't have to go ask you or go pull something out of a drawer. A heavy message is one that is fully self-contained. It has all the data, all the state needed for the receiver to do what they need to do. It's complete. And it's kind of like when you file a tax return, right? It's the whole thing. You send it, right? It's the whole thing. So that's a heavy message. It is complete. Now let's fast forward, and it's 2026. And I'm sorry to say, but you are still in the same job, and Todd is still your boss. Not a lot has changed, except now you're using something like Salesforce or some other CRM or bid prep tool. So what does that look like? So that's probably going to look like this. you open up the software, you compose your bid, and as you go, you're saving, it's auto-saving, into some repository, right? It's going into some database. And then eventually, you're ready, and you click submit. And what happens is a Slack message pops up in Todd's thing, or an email, or whatever your messaging platform is. Todd gets notified. He's out on the golf course, looks at his phone, he's like, oh shit. Okay, eventually goes back to the office. And then when Todd reviews your bid, he has to open it back up from that database, right? The message itself was just, you have something to review. Here's the number, here's the date, maybe here's the customer's name, here's the total amount, right? Just the summary, really just the Post-it note, but not the actual printed out document. So this is a light message. So light messages are like notifications or events. Hey, something happened, you might care about it, you need to take action. Heavy messages are like, here's the thing, process it. Make sense? That's the distinction I make. And I've written apps that use either or, and sometimes both. I just want to bring this up so that you can think about it. You're like, okay, what is the relationship between the sender and the receiver? And there are pros and cons to both. The light messages, the eventing way of doing it is very natural and intuitive. We all work in a world where we get lots of notifications and events and we go take action. It's clean. But the heavy message has an advantage of being self-contained and actually truly decoupling the systems. Because as you can see with the light message, there is some behind the scenes coupling. Somehow there has to be a repository or at least an API or something that allows the receiver to get what they need. But the downside to those stateful messages is they're stateful. And so if something changes and you need to resubmit it, you now have two copies of the same thing and they have to be processed in order. Just like if you change a tax return and you submit a superseding return before the deadline, the IRS has to know, oh, we're going with the superseding return, not the prior return. So the order matters. Okay, so how do you write code to actually implement these two patterns? And probably the common some JSON serialized content when you create your messages.
Yeah.
So here we've got a little class called bid, which has a bid ID, a bid date, a customer, a description, and an amount. And if I want to send one of these, this would be a light message. I would just create a new bid. So it's bid 1,000 right now, Acme widgets for what is this? 25 million plastic pellets. And then I've given you two syntax options. The first one is to call the message constructor that takes a string. So there is you saw that in my very first send example where you pass in a string. So in that case, I'm serializing it. JSON serialize the bid, and that turns this into JSON, which is a string. The cool thing is if you use this syntax for instantiating the message, where you set the properties as part of the constructor like this, the body property actually will do JSON serialize.serializer for you in its setter. So this is very cool. So when you do it this way, you end up with that in the body of the message, which is nice. They both work. So what if you want a heavy message? Okay, well, the body of a message is actually binary data. And I believe it's up to like 100 megs if you're using AMQP WebSockets. They can be very, very large. So in this case, I'm just reading the file into an array of bytes. And then I create my message and I say subject equals serialize the Post-it note, right, the summary. And the body it's a binary data using that bytes. So there's your full heavy message. All right, so that's how you do it. The last thing I want to talk about when it comes to payload is correlation IDs. So has anybody used correlation IDs? You all know what these are for? Nope. Okay. If you don't remember anything else from this talk, I want you to remember that I had a very cool cat shirt, and I want you to remember what correlation IDs are. Those are your takeaways. So in a multi-service environment, whether it's the counter in the kitchen or the order taker, pick, pack, ship, email, bill, book, return. The problem you have in these systems is correlating the journey of a request across them, right? You ordered cat socks. So the shipping service shipped you cat socks. The billing service billed you for cat socks. But how do we know that it's the same event, the same order, so to speak? So in that case, you might think, well, you could just use order ID. But different systems have different kinds of ways of describing orders. So a correlation ID is a piece of abstract data, usually a GUID or just some long number, that follows all the messages through the chain. So the way you implement this is the very first sender in the whole chain invents and assigns the correlation ID. And then every receiver after that has the responsibility to read it, use it in their log messages, and pass it on if there's a subsequent link in the chain where they send a message. And then it is beautiful. I've done services where we used, say, Datadog as a log drain, where all the different systems are just getting hoovered up into this log system. And all I have to do is, if I have a correlation ID, I can just search on that and I will see the messages from every single service related to this one request. So it correlates stuff across these boundaries. It is so important that Microsoft made it a top-level property of Service Bus Message, and there aren't that many properties. So strongly recommend that if you're building service message-based applications, you just use the correlation ID property. Yes, sir.
And Matt, two questions on this. One, first question 0 is, why does it have to be a string when a GUID why did Microsoft decide not to make that a GUID property?
I guess just for flexibility, you can encode anything as a string. So let's say you wanted to use a number. Let's say you just, for some reason, or let's say you liked GUID, for some reason you didn't want to use a GUID. You wanted to use a hash of something. I don't know.
Yeah.
So
and that's actually my second.
I wasn't in the room when they made this decision.
Right.
But I think it's flexible.
But which actually is really my actual question is, if it's so important, why is Microsoft asking me to initialize it for them? They should just be giving me a correlation ID. I'm wondering, what am I not getting about the architecture that they don't just go ahead and give you a correlation ID? Why
they don't know if you're the first. They don't know if it's up to you to assign it. You have to decide where the first step in the chain is. The first step.
Mm-hmm. Oh, it's just not built into the constructor. Okay.
Well,
I'm just really lazy. I hate having to do things myself.
Yeah. So this is an object initializer. So this way of building an object in C# is called object initializer syntax. And the constructor actually doesn't complete until this semicolon.
Mm-hmm.
So by using the public read-write property correlation ID, you can effectively do it in the constructor.
Okay.
This is a newer style. Older library, if you've been, right, I started with C# too. And in original C#, you would have 17 overloads, right? Every constructor would have 17 variants. And some of them would have 1 parameter and some of them would have 12. And you'd sit there in the little drop down reading through them to find out the one you want. They've really moved away from that as a style. Newer libraries like Azure Service Bus tend to have simple constructors, maybe 1 or 2 or 3 of them, and then they provide public properties and expect you to use object initializer syntax and just choose the thing. And in a way, it's way better because with those other way of doing it, you then it's like, is it a required parameter? Do I use names? I think it's a good design choice overall. It makes the code a lot easier to read because it's not order dependent. Also, now we're waxing philosophical about C#.
Yes.
This is a good style. By the way, for those of you who don't know, this thing here, new what, right? This This is in C#9, or 10.
Yeah.
This is called a target typed constructor. And the way a target type constructor works is you declared the class, you called a constructor with a set of parameters, it figured out which constructor to call.
Yes.
And this lets you get rid of var, okay? If you're like me and you're sort of var allergic, now you can do it because you don't need to say var message equals new service bus message. You just say it's a service bus message. You figure out the constructor. So I love target typed constructors. You have to really be intentional to use them because GitHub Copilot will never suggest the syntax to you. I mean, all the examples, they haven't converted them over. All of the AI tools have been trained on all this legacy code, but I strongly recommend people move to this style. Okay, good questions. Let's, if that was enough, let's keep going. All right, so now we're getting into the nitty gritty. So if you need a sip of coffee or something, now's the time to take it. All right, receiver modes and options. So I already mentioned this, that receive message async has a timeout. How long is it going to await for a message? By default, it's 60 seconds, but you can control it. So here I've made a time span of 5 seconds, and I just pass that in when I call receive message async. And so if there's no message, it hits this line of code after 5 seconds instead of 60. So that's pretty important, pretty simple. And now we get to the one that takes some explaining, which is your receive mode. There are 2 receive modes. One is called peak lock, and one is called receive and delete. Peak lock is the default. And most of the code examples and other things you'll see all use peak lock. But there is a simpler mode, which is called receive and delete. And because it's simpler, I'm going to teach that first, and then we'll dig into peak lock. So you need to kind of build a mental model here. I'm going to wave my hands around a lot for this, of what's going on. So when you send a message to Azure Service Bus, you send it, and the cloud, Azure, gets your request, and it makes a database record somewhere, right? It records your message in some database, and it tells you got it, and you're done. Okay, so your message is sent. So now there is like a record somewhere in the cloud. Now, when the receiver comes by and says receive, the cloud, Azure, says, okay, here's a copy of that message. So there's the question we're going to focus on is what happens to the database record? Like, here's the message. What do you want me to do with the database record? With receive and delete, it just deletes it or marks it as gone. When it's soft, I mean, it's probably a soft deletion of some kind. But with receive and delete, as soon as you request the message and it comes to you and you have your copy, it is gone from the queue itself. There's no retry. There's no mulligan there. You have it. You have to process it. And if you lose it and drop it and break it, it's gone. So this is very simple. It's actually the way most people imagine that queues work in the first place. When I receive it, it's FIFO, right? Remember that slide way back here? In this slide, M1 is not in the queue anymore. As soon as I receive it, it's gone. That's receive and delete. So it's very simple, and it's elegant, and it works. And if it works for your use case, then the way you need to do it is you create some service bus receiver options, and you tell it, I want to use receive mode of receive and delete. And then when you create your service bus receiver, you tell it the queue and the options. And then when you receive messages, they just automatically get deleted. So far, so good. It's simple. You don't need to overthink this one. Peak lock, okay, peak lock's a little different. So what happens with peak lock? So the message is in the cloud. It's some database record. And you say receive it. Here's what happens. Azure gives you a copy of the message. Here you go. it marks the message as locked. It puts a peak lock on it. And it starts a timer. Tick, 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 tick. You are responsible for making a second call after the receive, where you tell the server what your intentions are, what completion action you want. So you're responsible. Receive it, and then before the timer runs out, complete it, or something else. Abandon it. We'll go through the options. So you have to make that second call. While the message is peak locked, if let's say you've got a multi-threaded application with multiple receivers, if another receiver does receive, they're going to get the next message. Your message is hidden, right? You can't get received twice. And if that peak lock expires, it unlocks it and it pops back in. And then if you receive it again, you'll get it again. So it kind of disappears and maybe comes back. So what are your completion actions? You have 4 possibilities of what you're going to do with this message. The first is called completing it. You complete it by calling complete message async. So I mentioned that in my very first receive slide, said I would come back to it. The message is removed from the queue, and this is what you do for normal, successful message processing. So again, think it through. You said receive, Azure said, here's your message, and it's locked. You did whatever you were going to do with it, fired off your emails or whatever you needed to do, and when you're done, you say, that was good, complete it, and it goes away. That's completing a successful message processing sequence. So you have 3 other options. The next one is dead letter. You do that by calling dead letter message async. In this case, the message is immediately removed from the queue and placed in a special dead letter queue. And I'll go back to the slide, but when I showed you those message counts in your queue, maybe you remember it said messages, active messages, dead letter messages. So you automatically get this special parking place for dead letter messages. This should be used when a message is not processable. Okay, it's a poison message. No matter how many times you try it, it's never going to work. It is possible to replay the messages out of the dead letter queue using the Azure portal or CLI or various tools. I do not recommend this. And if you find yourself where you've deployed something and you are constantly replaying dead letters, you have a design issue. And we'll talk about that later when we talk about fault tolerance. But one of the problems is it totally screws up order messaging, because now all your dead letter messages are behind anything that came after them. Another problem with it is, in my experience, you lose the correlation IDs, and I don't know why. That could be the fault of the tool I'm using. So dead letter is for, we're just done with this. It's not going to work. Abandon is done by calling abandon message async. And this is when you want to retry. Like the message might be processed, so you want to put it back and retry it later. This is where you get your retry mechanism. So what happens? Well, the message is unlocked, and there's a retry counter, which is incremented, or a receive counter. So this is used when the message might be able to be processed in the future, so you want to put it back in the queue and retry later. The number of allowed retries or receives is configurable. And when a message hits that max, the next abandon will send it to the dead letter queue. So the default is 10. So let's say you have a message and you abandon it 10 times, it's going to go dead letter at that point. The fourth option is deferring. And this technically has the message staying in the queue, but it's marked as deferred. And in order to receive it again, you have to jump through some hoops. You need to have a sequence number, you call some special methods. I personally feel like this approach creates really complex message ordering and access issues and should be used with caution, which is a polite way of saying I've never used it and I've never found a use case for it. Now, if one of you is like, oh my gosh, defer saved my life, here's the real world use case, please let me know, because I've been bad-mouthing this feature. But I just think it's too complicated, but for completeness, it's there. So mostly you're going to complete, dead letter, and abandon. Now, as I've mentioned, there's a lot of things you can configure. One of the things is the peak lock expiration. So if you receive the message and a minute goes by and you don't do anything, that counts as an abandon. The server gives up and it's like, I don't know what happened to you. I'm unlocking the message. You can change that. And I think the max is 5 minutes. And I literally had an application where what we were doing, the reason we were decoupling it is that we needed to do some very laborious REST API calls to another service. And for any given message, it could be anywhere from like 1 to 50 of these REST API calls, depending on what we were doing. And in the production environment, they were pretty snappy. And it was taking about 5 seconds to get through, on average, to get through each message. So we were well under the minute. But in the lower levels, where we weren't paying for the production, it could easily spill over a minute. And we were getting crazy timeout exceptions. So we just expanded the peak lock to 5 minutes to give ourselves some headroom so that we could take our time, process all these REST API calls, and not have it just time out on us. The delivery count, or the receive count, is also configurable. The default is 10. You have some other things to configure, but those tie into this peak lock expiration conversation. Okay, so I'm going to pause there because that's probably the most complicated thing, is how peak locks work. And kind of, we're going to come back to it a little more, but that's like the fundamental thing. So any questions on that?
Yes. A couple of times, Matt, you talked about some of these message statuses as putting your messages out of order. And I am thinking, when I've used queuing, I haven't used queuing a lot, but when I've used queuing, the messages are totally independent. It's like, this customer wants a burger, this customer wants a burger, this customer, there's no sequence. It's fine. You get to them when you get to them. But I can imagine doing an app where the customer wants, metaphor, the customer wants a salad, then an entree, then dessert. I want to put those 3 things on the queue, but I don't know what order they're going to get picked up in, but I want to make sure they get their salad first, right?
Right.
Does this service even have like a concept of make a queue item dependent on a different queue item, or are you just kind of taking your chances?
No. You would have to build that logic. It's in the order they were sent.
Okay.
So you would have to control that at the sender level.
Yeah, and if I got multiple consumers, if I'm feeding in these orders at the front end of the queue, and the back end is being served by maybe 8 different cloud servers, I can't. There's no guarantee. Yeah.
Yeah, probably. So one thing, I mean, again, we were stretching the metaphor a little, but in this case, you don't really care if table 1's salad comes before table 2's salad, but you do care if table 1's salad comes before their entree.
That.
So the sender needs to say, I'm going to send it salad, entree, dessert. And then it'll get processed, salad, entree, dessert. And then the other table is salad, entree, dessert. But this one's dessert could get there before that one's entree. That's
right.
Okay. Now, multi-threaded, we're going to talk about fan out, fan in. We're going to get to that in the patterns. And if you do a if you do a scalable receiver, like multiple people in the kitchen who can pull the orders off, then it does raise some questions about what happens if an order goes back, right? So
what if the dessert server is like too efficient?
But the plumbing, the Azure Service Bus plumbing isn't really solving any of that. The key here is you have to think about that logic. And if message order matters, then you need to pay attention to a few things. That's all.
Okay, thank you.
Yeah. That's a great question. And that's in part the point of this talk, is to start getting people thinking beyond just the initial, how do I send and receive, right? And thinking through, This is where the human intelligence and programming comes in. Right? Okay, we are doing really well. I've talked almost an hour. I think I can probably get done in about another 10 minutes. We're running a little over. Thank you guys for your patience. And I realize I was late. Okay, so we have a couple different ways to look. So far, I've shown you send one message, receive one message. That's not the real world. In the real world, you need something that's alive and receiving messages and just processing them. So one way to implement that, a beautiful classic programming pattern, is your message pump. So message pumps are all around us. Windows is a message pump with all the window events coming in and getting routed. So here is, I'm just going to read the code, right? Internal static async task message pump, where I have passed in a polling interval and also a cancellation token. So you've probably seen cancellation tokens. Cancellation tokens are the .NET way of implementing what's called the cooperative cancellation pattern. So cooperative cancellation pattern is like controlled shutdown. Instead of just pulling the plug on the computer, you're going to tell it, hey, I want you to stop. I want you to shut down. So this allows whatever it is that launched the message pump can then cancel the message pump gracefully. And it lets the message pump not just get obliterated between one line of code and the next, but actually go through a graceful shutdown. I have a YouTube video entirely on cooperative cancellation, one where I talk about implementing it yourself, and one where I think I just talk about the way Microsoft gives it to us. So it's a cool pattern. It's really neat. Go check it out on my channel. So, all right, so we have some things that are common, right? We have our queue. We have a client, which we're going to reuse. We have a receiver, which we can reuse. We have our timeout, which we're going to reuse. And then we can just say, I'm starting the message pump. And then this line, while not cancellation token dot is cancel requested. This basically is like while true, right? Forever, until somebody tells me it's time to stop. Somebody signals that they would like me to stop. So this is your infinite loop here, right? This is your long running message pump loop. So inside of it, what do? Well, we're going to await receiver.receive message async with our timeout. And if we got a message, we're going to process it. I don't know what's inside of process, right? That's your complex code that does something. And if that worked, then we're going to complete it. And then it loops and it does it again. So if there's 20 messages in the queue and process message takes a second, this will take 20 seconds to chug through the messages, and then it'll stop and wait for more. What's cool here is that this timeout on the receive, it creates a natural polling interval. If there's no messages, it'll just wait for, let's say you set it for 30 seconds. So you don't have to have a wait. You don't have to have thread.sleep or task.delay. You don't have to have a explicit waiter in there. You can just rely on the timeout. And then if something goes wrong, we log it and abandon. So this is a message pump. I've written these. It's a very nice way to go. Another thing that you have, an option you have, is to pull messages in a batch. Instead of one at a time, I can get 5 or 10 at a time. So the way you would do that is you need to know your batch size. And then instead of calling receive message async, you call receive messages, plural, async. And that returns an I read-only list of messages. So that's very cool. So you call that, and then after it returns, I'm saying, okay, I got 0 messages or 20 messages. And then I can loop them for each message in the array, process it and complete it. So there are a couple of subtleties with regard to this. So with the batch size, you are not guaranteed, in this case, to get 3 messages. For example, maybe there's only 1 message in the queue, then you'll get 1. But even if there were, say, 20 messages in the queue, you're still not guaranteed to get 3. you're guaranteed to not get more than 3. And I've seen this in practice, where my batch size was 10. I knew there were 30 messages in the queue, and it gave me 8, and then 9, and then 7, and then, right? But it never gave me 12. So that's kind of interesting, that batch size is a little bit of a flexible concept. It's a max. And then the last thing about this is very subtle, but really important. When you call receive messages async, and you're using peak locks, the peak lock timer starts for every message in the batch at that point. So let's just play this through. Imagine that you're doing batches of 10. And imagine that your peak lock, you're going with the default of 60 seconds. And imagine that normally your messages take 3 seconds to process. You have to make a call to SQL, a call to this, a call to that, and then you're done, right? 3 seconds. So a batch of 10 is going to take about 30 seconds. You got plenty of headroom, right? You're never going to time out because the 10th message is still finished well before the minute elapses. So far, so good. Now let's say that one of your dependent services is having a bad day. You don't know why. It's just slow. You're just not getting your normal performance. And suddenly, it is now taking 7 seconds to process each message. So message 1 is fine. Message 2 is fine. Message 3 is fine, all the way up to message 7. And then on message 8, you process it and you complete it, but you've run out of time. You're at 64 seconds. You've actually gone past the threshold. And so when you attempt receiver.completeMessageAsync, you're going to get an exception saying your peak lock expired. You no longer have that message. So that's a bummer, right? Because you already processed it, but you can't complete it, and now you've really got yourself in a tizzy. And then to say nothing of messages 9 and 10, which are also not processable. So there is a gotcha with batches, which is you do have to think about the overall timeout for the batch. Okay. The last thing to talk about with receiver patterns is the lovely and elegant service bus processor. So this is a convenience class that they give us, and it is actually a wrapper for one or more receivers. So it implements the message pump or pumps for you. And it exposes the messages to you through an eventing model, which is really nice. So the way you do this is you create a service bus processor for the queue. You wire up an event for when you receive a message, and you wire up an event for when a message is thrown in error, and then you call processor.startProcessingAsync. And every time a message is in the queue, your code here is just going to run. Your event code runs. And by default, it auto-completes. So when your code gets here to this last curly brace, it calls complete message async for you. So this is just very elegant and simple. And if you go on learn.microsoft.com and you try to teach yourself Service Bus, this is what they're going to show you because it's so simple and beautiful. But now you know what it's doing for you. Under the hood, you can have some appreciation for what this class does and what some of the side effects might be. Similarly, with on-error async, you can log your message and then it abandons the message automatically here. So I love the Service Bus processor. You can also use it with batches. You can mix and match these things. Your receive mode works with both. So you can combine these things in different ways. Okay, so if I stopped here, you all could probably go and write a serviceable Azure Service Bus app, but it might not be bomb-proof. So I just want to take a little time to talk about what I think are the most common failure modes that you ought to think about. And for the purpose of this conversation, I'm going to throw out yet another sample app. Imagine that we have a weather reporting app. So the kitchen example was, or the e-commerce is fanning out. A message comes in and it gets broadcast out to a bunch of different, services. This is fanning in, where you have lots of senders who can post to the weather report queue. So the idea is I've got weather stations out there reporting temperature and dew point and wind and all of that. And they are reporting into the weather report queue. And then I have a single processor that's crunching these. And its job is basically to read the weather report and update a SQL database. So let's imagine that we are using the Service Bus processor, and this is our on message received event handler. So the very first thing we're going to do here is we're going to read the body of the message, because we're assuming that the body of the message is some JSON that represents the weather report, the station ID, the temperature, the dew point, the wind direction, the wind speed, all that stuff. And then we're going to deserialize it into a weather data class. Now, who knows what happens if that JSON won't deserialize, if it's not valid JSON? What happens?
I'm guessing exception.
That's right, it throws.
Okay.
Literally, this will throw an exception right there.
That's good, right?
Yeah, it's good to know. Right? So what we're doing here is that's going to cause our on messaging error to happen. And we can just log that, right? We're going to log this. So here's my question to you. If you try to deserialize it a second time, is it going to work? No, right? I don't care how many times you try to deserialize this message, it is never going to work. So this is what's called a poison message. And a poison message is one that just can't be successful. And the trick to poison messages is identifying them and getting rid of them. Don't retry them, okay? This on message error is going to abandon it. It's going to pop right back into the queue and you're going to get it again. And then it's going to abandon and you're going to get it again. And what's going to happen is that exception is going to run 10 times before it goes to the dead letter queue. It's a total waste. So you do not want to retry these things 10 times, right? It's just, and so you have to identify them and get rid of them. So here is an example of poison message solved. So it's all that same code, except we're going to catch, we're going to try catch, and we're just going to straight away dead letter it. So in this case, I'm taking advantage of the fact that this is a known typed exception. So I can catch JSON exception, but there's other ways to do this. The high level concept is think about what could throw. Think about your poison messages and make sure you're writing defensive code that will target them. It could be that you deserialized it and you can look in the message itself and be like, oh, they didn't even provide a required field, right? Some validation type code. It doesn't have to be an exception handler. The point is, think about what constitutes a poison message and have a strategy to segregate them and dead letter them. Don't retry them. All right, next we have transient error conditions, which is kind of the flip side of this. So let's say that, again, we're in our same on message received handler. You deserialize it, and then, as I said, you're supposed to write something to SQL. So we're going to open a SQL connection, and we're going to write to SQL. So again, what happens if it fails to open the SQL connection? Once again, this will throw an exception. Now, it is very likely that at some future point in time, SQL Server will come back, right? We don't know why. Maybe a network problem, or you didn't pay your Azure bill. I'm not sure why SQL is down, but it will come back. So this is a transient error condition. There is no reason to abandon this message, but what you don't want to do is keep trying. So imagine what happens if you don't do anything, right? Well, I got the message, I tried to open SQL, it failed. So I abandoned it. And I got the message and I tried to open SQL and it failed and I abandoned it. And so it will do that 10 times, and then it'll dead letter it and move on to the next one. And then this is the anti-pattern called the dead letter factory. And you come into work the next morning and there's 69,000 messages in your dead letter queue. And you're like, what the heck? And they're all perfectly good. And it's just because some dependent service had a bad night. So the trick, the way to solve transient error conditions is to essentially identify it, get everyone out of the pool, right? The lifeguard is going to blow their whistle and say, there's lightning, everyone out of the pool. You're going to wait for the storm to pass, and then you're going to let everyone back in. So it's basically stand off and try later. This is a standoff pattern. So basically, here you go. Try all that same code to process the message. Catch, in this case, it was a SQL exception. We're going to abandon that one message. That was the canary in the coal mine. We want it. So we abandon it. And then we pause the processor. So that's my little function that says await processor.stop processing async. We pause the message pump. And then I drop into this 1-minute polling loop where I'm like, okay, test the SQL connection. And if SQL's back, then start processing async, right? So this is like blow the whistle, everyone out of the pool, wait for the storm to pass, and then let everyone start swimming again. So again, I did it one way here by catching a SQL exception. There are other ways. The key is to make an inventory of your dependent services. Anything that you're calling that if it's offline, you're needing your host. You're not going to be able to process messages. You identify them and you stand off and wait if they've gone down, and then you can process again. So this is a real thing. Like, this is absolutely real world stuff, and people have this experience of just stuff piling into the dead letter queue. If you've done this right, my personal view is the only messages in the dead letter queue are poison messages. Everything else is valid and will eventually process once all your dependencies come back. Okay, so let's wrap up. Just in summary, right? At the surface, Azure Service Bus is simple and elegant, and it's just a way to connect applications using messaging, and it's straightforward and solves a real world problem. However, you have some real choices to make. Are you going to use basic queues, or do you have a use case to fan out with topics and subscriptions? Are you going to use heavy stateful or light stateless messages, or both? Are you going to stick with the default peak lock, or do you have a use case that supports receive and delete? Are you going to use the lovely Service Bus processor, or you want to roll your own message pump? Does your phone squawk like a chicken? Okay, I don't have to take that call. Are you going to pull one message at a time, or are you going to use batches? And are you going to kind of enforce strict FIFO ordering, or not worry about it as much? And basically, the last thing, do you have a strategy in place for abandoning and dead lettering, like knowing when you need to retry and when you're not going to retry? So there you go. Now, I'll take questions, but real quick, in case some people need to go, feel free to connect with me on LinkedIn. That'd be great. Please go to my YouTube channel. I love it when people watch my videos. I love it more when they like them and subscribe. And I'm not making money off of this. That's not the point. The point is, if you're interested and you like and subscribe, then somebody else out there like you who may have similar interests is more likely to get it in their search. So that'd be awesome. And this particular talk has a repo that goes with it, github.com, C# Artisan, Azure Service Bus demo. And it's a command line tool that you can run. You have to configure your connection string and your queues, and then you can run it, and you can actually test every technique that I showed you: send, receive, batches, a message pump, Service Bus processor. You can just step through and actually practice all of the code that I showed you. So there you go. You're on the bus.
Excellent. Thank you, Matt. I just wanted to pause for a second and give everyone a chance. If you have any questions or comments, feel free to make yourself known. We got several thumbs up, and
I do have one question, Sam.
go ahead, Jeff.
Matthew, I'm kind of curious. When I'm just getting started with Service Bus, and in the portal you have enable partitioning. I'm also a heavy user of Event Hub, so I use partitioning there, and I'm wondering if it's similar and how the client responds. If you're in a competing consumer, if you will, and I have like a device ID. This is an IoT. I want the device ID, to the events to stack up ordered behind that, but other than that, I don't care. But it's the same message, same topic, same subscription.
So I don't know about partitioning. I'm gonna just say I don't know.
Okay.
And yeah, Rick is posting a cool link there. And if you have different devices and they're sending them messages and they need to process their own messages, that's a good use for the for topics and subscriptions. Each device just gets a subscription. That makes sense.
Okay. Well, thank you.
Yeah, there's a lot of other little features and doodads when you look at Azure Service Bus, like filters. There are event filters. That's another way to do it. Is if the message has some data that you can filter on, you can use the concept of an event filter to break it up. And I should mention, I have this follow-up slide here, which you're kind of touching on, because there are other Azure things that are in the same family: Event Grid, Event Hubs, and storage queues. And it's like, why do we need all these different solutions? But they really kind of do solve different problems. And Service Bus is, as I think I tried to point out at the beginning, this is for high value enterprise messaging, where each message is important and counts and is going to do something. And where applications are like order processing and financial transactions. So I just copied these screenshots off of learn.microsoft.com. And I'm not an expert in Event Grid, Event Hubs, or storage queues, so I can't get into the subtleties of the difference. But I know the value of Service Bus and which problem it solves.
Very good. Thank you.
Hey,
We also
Matt.
have a question from Rick.
Yeah, so we talked a little bit about the coding side of Service Bus. How about management and/or monitoring tools? I found that the Azure tools are a little lightweight on the ability to actually dig in and monitor your message queues, see how much stuff is in there, where much less even being able to pull or peek into messages that are in the queues. Can you recommend any tools or open source projects?
Well, I agree with you. Through the portal, there are some things, and I believe there are also some third-party things that do this. And there's actually a separate API, which I didn't cover, which is a management API. So I have also written code when I didn't need a full-blown tool, but I wanted to incorporate some things like what's queue depth, right? Like I wanted to ask a simple question, like what's my queue depth? There is an API that gets you that, which is separate. So that's one way to do it, is to just be like, well, what do I really need, and write it. And one of the cool things I did use is just an example. We deployed one of these using KEDA, K-E-D-A, which is sits on top of Azure Kubernetes Service, AKS. And it does, you can do things like you set up YAML files where your services get instantiated and come to life, triggered by the presence of an event in a queue. In other words, your queue listener thing doesn't have to be alive all the time, but KEDA will kick it off as a microservice. And if you have multiple readers, you can kick them off. But in terms of the monitoring, honestly, I've just relied on logging. And a good logging tool like App Insights or Datadog, and some Logdrain. And many of those tools, such as Datadog, give you notification capabilities. So I feel like that's worked pretty well. Let Datadog monitor the messages and read the messages. And if it sees a message of a certain profile, it can send you an email. And then if you include some of those facts like queue depth and response time, if in your code, you instrument your code a little bit, you can include that in your messages, in your logging. So that maybe seems kind of hacky to you, but it has worked pretty well. That's probably all I can say. Does that make sense?
Any other questions? Matt, if I could ask you, oh, perfect. You beat me to it. Thank you. And thanks for a very insightful presentation. It was very informative. And I'm sure, judging from everyone else's comments, they agree. So job well done. And if I may, I'd like to take back the screen and just share a few things for concluding. All right. So I shared a couple links in the chat window. There is the link for the YouTube channel. If you would please subscribe to that to get the upload notifications. The video for this presentation will be uploaded just in a few short days after the editing process. In addition, my blog, samnasser.blogspot.com, I post a lot of technical articles as well as tech events. So if you would please subscribe to that as well to get updates on local tech events or regional tech events. And last but certainly not least, the feedback eval form. Please take a moment to fill that out so we can provide Matt with some constructive criticism. And as a bonus, once you fill out the form, you'll be in the drawing for receiving a license for the UNO platform for developing cross-platform .NET apps. So it's an added bonus for filling out the eval forms. Also, one of the things that we always like to discuss is jobs, jobs, jobs. So who's hiring and who's looking for work? If you would please make yourself known. Anyone have any open positions in their organization? Anyone currently in the job market?
Give me a second, Sam.
Sure.
Meyer always has open jobs. Let me check the website real quick.
Okay, no problem.
I would suggest that if you're interested in retail IT positions, jobs.meyer.com, and then once you're there, you can search for jobs. You generally want to search for the Grand Rapids area, even though most positions nowadays are remote, and there's always something open, in a variety of IT positions. So just search either for the Grand Rapids or for filter down for information technology positions.
Okay, very good. That's a very good tip. Most people would probably just went to the website and just search for their local area, not knowing a lot of the positions are remote. So thanks for the tip.
Sure.
Mark, did you have something else you wanted to add? Maybe not, or maybe struggling finding the mute button.
Yes, Mark. No, my dog is just being bad.
Okay. So he's not in the job market then, I take it.
Oh no, no. Vuvu is solidly employed hunting badgers.
Very nice. Good to hear. All right, so we'll wait for Rick to post a link in the chat window. And also, someone else had posted their LinkedIn, which I invite you all to do so. I think it's a great way to network and share your LinkedIn profiles. So thank you for doing that. And Rick, thank you for the link. In addition, also wanted to mention that if you are in the job market, check out devitjobs.com. So this allows you to search by technology, by region, whether remote or in person. So it's a great website for searching local positions. Also, wanted to take a moment and share some websites with you. So first is youtube.com/@C#artisan. And that is Matt Hess's website. And you'll notice there's a lot of videos there, short clips in the 5 to 20 minute 5 to 20 minute range. So a lot of quick clips for various things on C#. Also wanted to mention that the C# meeting, the Cleveland C# meeting to be exact, that's going to be held on January 28th, which is a Wednesday. It's going to be later this month. and the topic will be resilience for building stronger teams. And that's going to be done by Jason Erdahl from Minnesota. So if you're interested in stronger team building, I strongly urge you to register for this meetup. And this link will be posted on my blog, as well as other tech events that will be happening. Also, I had posted a link for a quick start for working with the message bus queue. And if you'll notice that over on the left-hand side, each topic is expandable. So the example that I posted is for .NET. However, there are examples for JavaScript, Python, TypeScript. And then in addition, there are other topics relating to subscriptions and subscribe for messages. So feel free to check that out. And that link is also posted in the chat. Lastly, my contact information, should you have any questions, feel free to reach out to me, snasser@nistechnologies.com. You can also find all my socials and links on Linktree/Sam Nasser. And like I said before, let's connect on LinkedIn. Let's share our LinkedIn profiles, connect with everyone, and build up our network. And so with that, thanks again to Matthew Hess, and thanks to all who attended, and look forward to seeing you all next month. Good night, everyone.